Good morning. This is another one of the topics that we didn't get to in class, but that's just during this spring 2020. If you're watching this another time, you probably got to it. So we're just going to talk quickly about function notation. It is just another way to keep track of what x's you're substituting in. So basically, the letters f of x, it could be another letter here, like g of x or h of x or whatever, but f of x means the same thing as y. So if you see y or you see f of x, it means the same thing. So what I mean by that is right here, f of x equals 2x plus 1 is the same as saying y equals 2x plus 1. The benefit of using function notation is that it kind of holds your x so you can see what you used, what you substituted in. So it would be kind of like saying, I'll just show you. Okay, so it kind of acts like a machine where you take whatever your x is and you substitute it into the machine, and then it spits out what the y is. All right, so let me show you how that works. So if we were going to do f of 3, what that means is that you're going to take this x, this is what x equals 3, okay? You're going to take that and you're going to substitute it into the machine. You're going to put a 3 inside. That means anywhere you see an x, it becomes a 3. And then you use the order of operations to simplify the expression that you have inside. And out comes the answer. 2 times 3 is 6, plus 1 is 7. So f of 3 equals 7. What that means is that when x equals 3, y equals 7. So you may remember from class when we would make a chart like this, x, y equals 2x plus 1, y, and then it would give us a coordinate at the end, like that. That's the same idea. We put in a 3, 2 times 3 plus 1 equals 7, so we have the coordinate 3, 7. All right, and you could graph that. So let's look again one more time. Or we're going to do it 2 more times for this problem, actually. All right, so we have the same function. This time we're substituting in -1 for x, because like this means x equals -1. All right, so where there was an x, we put a -1, and we use the order of operations. 2 times -1 is -2. -2 plus 1 is -1. So when f of -1 equals 1. -1. Sorry, I couldn't read my handwriting. All right, and again, you could look at it the same way as this chart. If you substituted -1 for x, you end up with -1 as your answer, and you have a point, -1, -1. All right, again. Now we have f of 0. So that means x equals 0. So we're going to substitute into the machine 0 for x and use the order of operations to simplify the expression. 2 times 0 is 0. 0 plus 1 is 1. So when f of 0 equals 1, which means when x equals 0, y equals 1. And we have a coordinate, 0, 1. All right, so we're going to do 2 examples just to make sure that you get the idea. All right, now I don't have a function machine drawn this time, so I'm just going to do it by hand. All right, f of x equals x squared plus 3x minus 4. F of -2, remember that means that x equals -2. Everywhere we see an x, we're going to put -2. And remember, we substitute using parentheses to hold the spot. All right, simplify using the order of operations. Remember the order of operations: group, exponent, multiply or divide, and add or subtract. All right, let's look. Do we have any groups? We have parentheses, but not groups, because there's nothing to do inside of those parentheses. So we're done. Exponents, yes, we have an exponent right here. -2 squared means -2 times negative 2, which is positive 4. Any more exponents? No. Multiply or divide left to right. Right here. 3 times negative 2 is negative 6. Multiply and divide is done. Add or subtract left to right. So 4 minus 6 is negative 2. And we have more add and subtract is negative 6. So f of negative 2 equals negative 6, which means the coordinate negative 2, negative 6. All right, let's look over here at the next problem. F of x equals 3x squared plus 8. We want to find each of these. So that's like putting it in the machine 3 times. All right, so for f of 3, I'm going to write it down here. F of 3 equals 3. And everywhere we have an x, we're going to substitute 3. All right, use the order of operations to simplify. No groups. Yes, exponents. So 3 times 9, because 3 squared is 9. Multiply or divide. Add or subtract. 27 plus 8 would be 35. So f of 3 is 35, which corresponds with the coordinate 3, 35. All right, f of negative 4. Let me use a different color so you can see, since now my paper is kind of a mess. F of negative 4. So now we're going to substitute everywhere there was an x. We're going to put negative 4. Use the order of operations to simplify. Exponents. So we're going to have 3 times positive 16, because negative 4 squared is the same as negative 4 times negative 4. All right, 3 times 16 would be 48. And then add and subtract. 48 plus 8 would be 56. So f of negative 4 equals 56, which signifies the coordinate negative 4, 56. Okay, and lastly we have f of g. That one's kind of strange. Let me cover up this bottom so it's not distracting. We're going to use the same process. Everywhere that we had an x, this time we're going to substitute a g, which is really weird, but hey. All right. Now, using the order of operations, there's nothing to simplify because we have a variable there. So f of g is equal to 3g squared plus 8. So basically, all we did was change the x's to g's. All right, I hope that was a good introduction to this, and I hope you have a great day. See ya.